prove that x cubed equals 3x squared plus 2 has at least one real root. Now, if we subtract 3x squared plus 2 from both sides, we can move all of the terms to the left. So x cubed minus 3x squared minus 2 equals 0. And we can call that function f of x. So looking for a real solution here is equivalent to looking for a real root of this trinomial. And this is a continuous function. All polynomials are continuous for all real numbers. So what we need to do is we need to make a table of values and hope that we can find x values that give us both a positive and a negative function value. And once we've done that, then we know by continuity and the intermediate value theorem that there will be a real root in between those. So let's pick some values. 0 is always easiest to start with. If we plug in 0 here, 0 cubed is 0, 3 times 0 squared is 0, and we're left with that constant term, which is negative 2. So we've got a negative value of f of x, which means we're hoping for a positive value. We could try plugging in 1. If we do that, that's 1 cubed minus 3 times 1 squared minus 2. 1 cubed is 1, minus 3 minus 2. That's going to be negative 4. So we still have a negative value. If I think about this, I know that x cubed usually grows faster than x squared if we pick a bigger value of x. So let me pick a larger value of x. Let's try 4. If we do that, that's going to be 4 cubed minus 3 times 4 squared minus 2. 4 cubed is 64 minus 4 squared is 16, and 3 times 16 is 48 minus 2. 64 minus 48 is 16, and 16 minus 2 is 14. So we've got a function value of 14. And now we can see that we've got an x value that gives us a negative value and an x value that gives us a positive value for the function. So by the intermediate value theorem, that tells us we must have a solution to the equation between x equals 1 and x equals 4. If we wanted to know even more specifically where it is, we could pick other x values between 1 and 4 and try and narrow it down if we need to be more specific, but we weren't asked to be here. We just wanted to prove that there was at least one real root, and we have done that because we've got a continuous function and we've got two x values that give us a negative and a positive function value. So we know by the intermediate value theorem, somewhere in between there, that function is equal to 0, and that gives us a solution.